we're talking about all the different ways that you can solve limits using an equation. So let's go. There are 4 main strategies for solving limits. Let's get started. So the first strategy, all we're going to do is plug in the x value they give us. So in this problem, they have x goes to 2. So all I'm going to do is plug 2 into my x value. 2 squared plus 4 times 2. That gives us 4 plus 8 for a total of 12. For the next problem they want is x goes to 4. X is going to 4, so again, all we're going to do is plug in 4 to our x values. So 3 times 4 plus 4 minus 4 squared. That gives us 12 plus 4 minus 16. You've got 16 minus 16. You got a big fat 0 for that one. All that work for 0. For the next problem, we're doing the limit as x goes to 3. So again, we're just plugging 3 in to our x value. So in the numerator, you have 9 plus 15. In the denominator, you have 12. So numerator is 24 over 12, which gives you a total of 2. The limit is heading to 2. Let's try an example where x goes to -1. 3 times -1 minus 1, all over -1 minus 1. We've got -3 minus 1 over -2. -4 over -2 gives us +2. Now let's try this problem and see what happens. We have as x goes to 2. So you'll have 2 squared minus 4 all over 2 minus 2, which leads us to 4 minus 4 over 0. And what happens when you have 0 in the denominator? That's a no-go, right? Cannot have 0 in the denominator. Therefore, we tried plugging it in, but this leads us to our second strategy. When plugging it in doesn't work, you have to try the next strategy in your toolbox. And the next strategy we have here is factoring. So this is the same problem, and now we're going to factor to show you how to do this problem. We're going to take the numerator, we're going to factor. However, you still have to write the limit as x goes to 2 if you still have your variable in the problem. So the numerator is going to factor down to x plus 2, x minus 2, all over x minus 2. Now, does the denominator have to be in parentheses? No, it does not. But sometimes I just like to do that because I'm going to show you here our little trick. Anytime you multiply by 1, your problem doesn't change. So hopefully you saw a 1 in this problem disguised. Do you see it? This is a big old 1. When you have the same value in the numerator and the same value in the denominator, you have a value of 1. So then where does this leave us? Now we're left with the limit as x goes to 2 of x plus 2. Now at this point, all you need to do is plug in your x value. So we have 2 plus 2, which equals 4. Let's try another problem where we need to factor. Now you always want to try to plug it in first. So that's what I'm going to try to do because that's always your easiest solution. The issue is the denominator. So I'm only going to plug this number in on the denominator to see if it gives us a 0. If we plug in -1, let's see what we get. We have 1 plus 3 minus 4. Well, of course, that gives us 0, which is no good, which means we need to try a new strategy. We're going to try to factor. So we're rewriting the limit as x goes to -1. We have to keep this in because we have not taken out our variable yet. We're going to factor the numerator first. In the numerator, you need two numbers that multiply to give you 5, that add to give you 6. So in this problem, we've got 1 and 5. In the denominator, we need values that will multiply to give you -4 and add to give you -3. So in this case, we're going to use 4 and 1. And because our negative is in the center, our bigger integer needs to be negative. And now hopefully you're getting excited because you see a 1 disguised as x plus 1. And when you see this guy disguised as x plus 1, it's great because multiplying by 1 doesn't change it, so that guy drops out. And now we can go ahead and plug in our x value, -1 plus 5, all over -1 minus 4, which gives us 4 over -5. So your answer is -4/5. Now let's try a trickier factor problem. You can easily look at this problem and see that we're going to have a 0 in the denominator, so that's no good. So we must go ahead and try our second strategy, which is to factor. So rewrite the limit as x goes to 1. In the numerator, we're going to have x squared plus 1 times x squared minus 1 over x minus 1. Hopefully you remembered how to factor that numerator. If not, and you're not sure, go ahead and factor that out to see how we get back to x to the 4th minus 1. Now if you look, we don't have any tricky 1 or disguised 1 sticking out to us yet. But we do have another factor that we can break down in the numerator. So that's what we're going to do. We're going to rewrite the limit as x goes to 1. X squared plus 1 stays. But this next one can be broken down to x plus 1, x minus 1, all over x minus 1. Now you should be getting excited because now you're seeing our 1 here that shows up that will drop out of our problem, and now we can just go ahead and plug in our x value. So our x value is now 1 squared plus 1, keep those parentheses, times 1 plus 1, all over, well, nothing anymore because that dropped out, so we don't have to worry about that. Technically, it's over 1. All right, so now this guy is 2 times 2. So we get an answer of 4. All right, let's try another factoring problem. Again, go ahead and plug in the denominator. Always try plugging it in first. 2 squared would be 4 plus 2 minus 6, which gives us 0 in the denominator. We can't do that. So then we need to factor. So we have the limit. As x goes to 2, you have to write that, super important. Let's factor that numerator first. Again, we want two numbers that multiply to give us 4 and add to give us -4. So in this case, we're going to do -2 in each side. Then in the denominator, multiply to give us -6. Add to give us 1 in the center. So in that case, we need 3 and 2. And because the integer in the center is positive, our bigger integer on the bottom needs to be positive, which makes the -2. Which hopefully you should be getting very excited because then you see that 1 disguised again. So now we have that 1 right here, which means that's going to drop out of our problem, and now we can just go ahead and plug in our x value. So for this problem, we have 2 minus 2 all over 2 plus 3, which gives us 0 over 5, which gives us 0. So I have students who sometimes get confused. Okay, why can I have a 0 in the numerator but not in the denominator? And they get confused and they mix them up. So let me show you how this works. This is the trick that I have used. If you have a 0 in the numerator over some number n, this spells on. So this means this is all good and your answer will be 0. On means good. But if you have 0 in the denominator, you have some number over 0, this says, no, this is no good. We can't do this. That means your problem doesn't exist. You have to do further explanation. So try to remember, on means we're good to go. You can have 0 in the numerator. No means you're no good. And if you have 0 in the denominator, you need to do more investigation. Now this problem is going to require you to pull out some good old factoring skills. When you have a value that is cubed, we have to figure out if this other integer can be written as a cube. And it can be, and that is great. So what I'm going to do is remind you of the cube factors, how you can break this down. So this is what I call a little thought bubble here. And this is what we need to remember. If you have a cubed plus b cubed, that can be written as a plus b times a squared minus ab plus b squared. If you have a cubed minus b cubed, that is rewritten as a minus b, a squared plus ab plus b squared. If you don't have this already written down in your notes, make sure you write it down. Put it on a special sheet of paper that is your math go-to cheat sheet so you have these factors readily available. We're going to use this for this problem. In this problem, 8 can be written as a cubed, and hopefully you remember that it's 2 cubed. We're going to rewrite it as the limit as t goes to -2, and our numerator is t cubed plus 2 cubed, all over t plus 2. So in this problem, our t is our a value, and our 2 is our b value. That's the trickiest part. You need to make sure you're putting in 2 and not 8. So let's go ahead and I'm going to factor this out. So we have the limit as t goes to -2. Our numerator, t plus 2, t squared minus 2t plus 2 squared, which is 4, all over t plus 2. And now you should be getting really excited again because you see that 1 disguised is hanging out there. And now from here, all we have to do is plug in our t value. So we have -2 squared minus 2 times -2, plus 4, again, all over 1. That's just going to go away. So what do we have here? This guy becomes 4 minus, plus 4 plus 4, so we have 12. Remember, you always want to try to plug in first. So if we try to plug in x is 9 in this problem, we have the square root of 9, which is 3, minus 3 gives us 0. So we have to do some investigation. The next strategy is to factor. We can't factor this problem. So your third strategy is rationalizing. Okay, that's what we're going to work on in this step, and we're trying to get rid of the square root. So to get rid of a square root, you need to multiply it by itself. So we're going to use a fancy or a 1 that's dressed up in disguise like we were canceling out on our last problems, and we are going to multiply by a 1. Let me show you. I'm going to take this equal sign here. We're going to make it a multiplication symbol. And we are going to multiply by the square root of x plus 3, square root of x plus 3. And remember, the reason why I have to do this in the numerator and the denominator is because the only way that you can That's my attempt at making a 1. The only way that you cannot change a problem is if you multiply by 1. Your 1 can be disguised as anything you want it to be as long as it's the same in the numerator and the denominator. So this is what our 1 is going to look like. And let me show you how we're going to multiply this out. All right, we have the limit as x goes to 9. I do not want to mess with that numerator. All I'm going to do is put each of those pieces in parentheses because they are no fun whatsoever. Now, in the denominator, what we're going to do is factor it out. Square root of x times the square root of x is x. Square root of x times 3 plus 3 square root of x. Negative 3 square root of x minus 3 square root of x. Negative 3 times 3. Negative 9. So hopefully what you are seeing in the center here is that this positive 3 square root of x minus 3 square root of x totally drops out. And that's the whole reason I picked this factor, and I had, this one was negative, so I made this one positive, so when we multiply it out, those middle pieces drop right out. So now let's rewrite what we're left with. We have the limit. You have to write this anytime you still have your variable. As x goes to 9, in the numerator, x minus 9 times square root of x plus 3 all over, look at this, x minus 9. And you should be getting happy again because now you see another 1 that is going to go ahead and drop itself out. And now all we have left to do is plug in our x value. So when we plug in our x value, we have the square root of 9 plus 3. So we've got, this guy is 3. 3 plus 3 is 6. All right, let's try some more rationalizing. If we go ahead and plug in 0 to this, we automatically know we cannot have 0 in the denominator. Therefore, we must try a new strategy. Factoring is not going to work, so we have to rationalize. Let's check out this disguised tricky one that we're going to use. So this time, we need the square root of x plus 4 plus 2, which means we need the same thing in the denominator, because if we multiply by a 1, we have not changed the problem. I'm going to put all of these in parentheses, because then our next step is to factor that numerator out, the limit, as x goes to 0. So you are going to have the square root of x plus 4 times the square root of x plus 4, which leaves us with x plus 4. Then, square root of x plus 4 times 2 minus 2 times the square root of x plus 4, negative 2 times positive 2, negative 4, all over x times the square root of x plus 4 plus 2. Again, hopefully you're excited because what you're recognizing is this is the positive, this is the negative, those are going to drop out and just become a 0. Bonus, right? That's exactly what we want. Now, if you already know that, do you need to write that step out? No, absolutely not. I just want to show you why that drops out, but if you know those two middle pieces are going to drop out, you do not need to write that step. So what are we left with? The limit as x goes to 0. X plus 4 minus 4 all over x, square root of x plus 4 plus 2. Well, hopefully by now you're seeing that plus 4 and minus 4 are going to drop out and become 0. When they drop out and become 0, hopefully you see this guy becomes a 1. So at this point, all you have to do is plug in. Now remember, you have a 1 in your numerator. And on the denominator, you have the square root of 0 plus 4 plus 2. This is just a square root of 4, which is going to be 2. So you have 1 over 4, 1/4 for your answer. Now this one looks super ugly, all right? Try to plug in. We can't, right? Can't factor, so we must rationalize. We're going to multiply by the square root of 5 plus y plus square root of 5. All over square root of 5 plus y plus the square root of 5. Put this guy in parentheses because we need to factor this out. So we have the limit as y goes to 0. Square root of 5 plus y times the square root of 5 plus y. We're just left with 5 plus y. Now, this square root of 5 minus y times the square root of 5 is going to cancel out negative square root of 5 times this guy. So in this case, I'm not going to write out the middle terms because they're going to drop out. Now I just need to multiply negative square root of 5 times a square root of 5. When you multiply a square root times a square root, they drop. So we are just left with a negative 5 all over y times the square root of 5 plus y plus the square root of 5. Now, hopefully you see what's going on here. You have your 5 minus 5. Those become zeros, right? And now you're left with a y over a y, which is a 1. Yes, right? So moving forward, you have 1 in the numerator, and our y value, we plug in our y value, so we've got the square root of 5 plus the square root of 5, which gives you a total of 1 over 2 square root of 5. In the next video, I'm going to describe our last strategy. It's called the magic 1. We use this with limits when they're heading to infinity.